Mars. For several hundred years, we have been looking at the red planet with great curiosity. The Earth-like celestial body is the fourth in the solar system and the closest neighbor of the Earth. The planet has a diameter that is only half as large as that of Earth, but its weight is only a tenth of that of the Earth. This is due to its low density and results in a relatively low attraction force. Despite its distance of at least 56 million kilometers, Mars seems to be within reach. If you would like to leave Earth with us to travel to the farthest reaches of the cosmos, then show us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Let's begin our journey to the mysterious Mars. In November 2011, a NASA mission called Mars Space Laboratory was launched. It is intended to investigate whether the biosphere of the red planet is suitable for living there. In the course of this mission, an autonomous rover was sent to the surface of Mars to carry out investigations as well as taking photographs. Curiosity is equipped with a variety of devices. Among them are various instruments to analyze atmosphere and rock samples. In addition, the rover has several spectrographs and meteorological measuring instruments to collect important data, which are sent to Earth at regular intervals. Curiosity has the weight of a small car at about 900 kilograms and has been moving on the surface of the red planet for over 2,793 Sol, or Mars solar days. The landing took place on August 6, 2012, and the rover sent the first images back to Earth on the same day. Thanks to state-of-the-art technology, the rover is able to take 360-degree color panoramas and transmit them in full resolution. Curiosity is also capable of making selfies, which is mainly used to assess the condition of the rover. At regular intervals, for example, photos of the tires are taken in order to detect damage and deduce how long Curiosity will still be roadworthy. While some of the photos are very similar to landscapes on Earth, other photos show unique rock formations and rock shapes. For example, at first glance, the Martian sand dunes look very similar to dunes on Earth, but the size and shape, as well as the ripples, are only found on Mars. In order to gain deeper knowledge about the planet, boreholes are drilled again and again. Thus, the rover is able to take rock samples from deeper layers of the surface and analyze them. Did you know that Mars has 2 moons in its orbit? Curiosity has already been able to take pictures of both celestial bodies, Phobos and Deimos. You can see the irregular rounding of the moons, which are relatively small compared to the Earth's moon. The larger of the 2 moons, Phobos, has an extension of only about 20 kilometers. Olympus Mons. The Olympus Mons was discovered as early as 1879 by the Italian astronomer Giovanni Schiaparelli. This fact alone speaks for its enormous size. In 1971, a probe was in orbit for the first time. The probe, named Mariner 9, took pictures during a sandstorm. Olympus Mons was the first object to emerge and be captured on camera. Only later was it discovered that this was a volcano. About 2.5 times as high as Mount Everest, Olympus Mons rises about 22 kilometers into the air. With a diameter of about 600 kilometers, the volcano is the largest volcano known to us in our solar system. It is also one of the younger volcanoes on Mars. The origin of the giant is dated to the period of the Hesperian. The Hesperian began about 3.7 billion years ago and ended about 2 billion years ago. Strong volcanic activity determined the events on the red planet. While the atmosphere and the surface were still relatively humid and warm, the Hesperian changed the planet forever. Over the course of time, Mars slowly became the dry and cold desert planet we know today. Shield volcanoes like Olympus Mons were formed and lava flows ruled the planet, changing the weather conditions and landscapes forever. It must be remembered that unlike Earth, there are no plate tectonics on Mars. Only the strength of the lava rivers have been responsible for the formation of such giants. Of course, the attraction on Mars is much lower than on Earth. This is the only reason why it is possible for mountains and volcanoes to develop with such enormous altitude. If the gravity were the same as on our blue planet, Olympus Mons would almost certainly collapse. Whether the gigantic volcano is still active or has since ceased to exist remains to be found out. What's with the Martian face? The origin of Cydonia Mensae, a highland on Mars, has not yet been fully clarified. It is a highly complex landscape with unique rock formations. It is assumed that it is a former coastline which bordered the gigantic water surface Acidalia Planitia. In July 1976, the Viking 1 probe took pictures of a huge rock formation. It is a 1.5 kilometer wide and almost 3 kilometer long elevation, which is estimated to be 3 million years old. The amazing thing is that the formation bears a striking resemblance to a humanoid face. A few days later, the pictures were published and made worldwide headlines. That's how the familiar name came about, Mars face. In the immediate vicinity, other rock formations were discovered that strongly resemble pyramids. NASA wrongly called these rocks Inca City, even though the Incas never built pyramids. Mayan City would have been more appropriate. When pictures of the rock formations were taken again in 2001, they had little in common with a face. Can you still see the eyes and the mouth on the latest pictures? The low quality in 1976 and the interaction of light and shadow, as well as the tendency to recognize familiar forms, also called pareidolia, finally led to the phenomenon of the face of Mars. It is assumed that the face and pyramids were created by natural erosion. But such a discovery is predestined for pop culture and has already been a source of inspiration for numerous series and films. The face of Mars first appeared as a station for aliens in 1988 in the video game Zack McCracken. The face of Mars also plays a role in the film Mission to Mars by Brian De Palma. In the animated series Futurama, the face of Mars serves as the entrance to the world of the Martians. And even in the X-Files, the eerie cases of the FBI, a spaceman is haunted by nightmares in which the famous rock formation is present. Life on Mars. The idea of life on Mars is as old as the discovery of the red planet itself. In the 17th century, the polar caps were discovered on Mars, which led to the first speculations. Over the centuries, and as technology progressed and developed, astronomers and scientists discovered more and more similarities between Earth and Mars. For example, a day on Mars, called Sol, is almost as long as a day on Earth. A year on Mars, on the other hand, is almost twice as long with 687 days. The inclination of the axis is also very similar to that of the Earth at 25.19 degrees. This leads to seasons on the red planet. In the late 19th century, observations were made with a telescope that showed channels on Mars. In books that were published afterwards, people speculated that they might be the remains of a past civilization. In the end, the observations turned out to be an optical illusion. Nevertheless, these speculations led to further ones, and in 1897, the observations served as inspiration for the author H.G. Wells's bestseller, The War of the Worlds. In 1938, the book was staged in a radio play that resembled a real reportage. This led to confusion among many listeners and was perceived by some people as an actual newscast. Today, it is clear that a higher or equal intelligent life form does not exist on the red planet. However, it is not unlikely that lower life forms such as microbes could be present. Alternatively, other forms of life such as viruses and bacteria cannot be ruled out at this time either. The thin atmosphere on Mars means that water does not exist, at least on the surface. But once upon a time, that was different. Before the Hesperian, there was a completely different atmosphere on the planet. A warm and humid environment billions of years ago might indicate that life could have once existed, but so far, there is no evidence of that. What do you think? Was there a higher form of life on Mars? Since the end of the Hesperian, both the atmosphere and the surface of Mars have remained largely unchanged. This provides perfect conditions for research. The origin of life could also be traced back to Mars. One hypothesis is that life could have originated on Mars billions of years ago and was brought to Earth by meteorites. Currently, the main searches are for water and water residues, bio and gas markers. The first manned mission to Mars could succeed on August 2, 2048, because that is when the red planet is closest to the Earth. But Tesla founder Elon Musk has already discovered and made manned space travel possible this year. And he did so in the private sector without having to rely on the state or politics. The pioneer even considers it possible to enter Mars within this decade. Critics are skeptical whether there will ever be a footprint in the red sand, but if there is, it would be another big step for mankind. There is probably no more inhospitable place in the solar system than our neighboring planet Venus, often also called Earth's sister planet. This rock planet is so completely different than our lovely homeland. On Venus, it is hotter than on Mercury, and that although it's further away from the Sun than Mercury. The pressure on the surface of Venus is about as strong as in 3,300 feet underwater on Earth. It would literally crush a human being on the surface of Venus. But these conditions are not only deadly for organisms, technical equipment also fails very quickly on Venus. Visiting the surface of Venus with a probe was long considered impossible. Nevertheless, this technical feat has been achieved thanks to the Venera probes. Humans were recently able to see the bizarrely beautiful surface of Venus with their own eyes for the first time. Venus. Although Venus is named after the Roman goddess of love and beauty, the second planet in the solar system as seen from the Sun is a hellish place. Surface temperatures of almost 900 degrees Fahrenheit, an atmosphere enriched with toxins, and a pressure 90 times stronger than on Earth makes Venus a nasty celestial body in our solar system that you really don't want to get close to. Nevertheless, astronomers and physicists naturally wanted to explore our sister planet and had to come up with some ideas to do so. The demands on the technology, and especially the camera systems, presented engineers and designers with a great challenge. In the end, no one knew whether any terrestrial technology would be able to withstand the extreme conditions on the surface of Venus for even a few minutes. But another hurdle stood in the way of Venusian exploration. Venus wraps itself in a dense cloak of clouds all year round. Never before had researchers or astronomers been able to see the surface of Venus with a telescope. No one could know if a probe flying to the surface could even provide sharp images, or if Venus's toxic haze would reach down to the surface. Another challenge was Venus's unusual rotation speed and orbital direction. The beautiful Venus rotates around its own axis as slowly as no other planet close to the Sun. A Venus day lasts 243 Earth days, and thus longer than a Venus year. Venus makes its round around the Sun in only 225 days. This is not the end of Venus's peculiarities. It also moves around the Sun in the opposite direction. The only other planets with such a retrograde rotation are Uranus and Pluto. Now you may wonder how astronomers on Earth got the idea to name this strange, glowing hot and poisonous celestial body after the goddess of beauty and love. This can be explained actually quite simply. The inner planets were already known in ancient times, since they could be easily observed with the simplest telescopes and, as in the case of Venus, also with the naked eye. Venus shines for at least 7 months a year as the evening star, the brightest phenomenon after the moon in the night sky. If you have ever observed Venus yourself, you could see that this planet looks like a sparkling diamond to us Earthlings. The Romans could not have known about its toxicity many thousands of years ago when they named the planet after their goddess of love. However, it was only too well known by the middle of the last century that a probe flight to Venus would not be easy. And now comes another special feature of Venus. The pioneers of Venus exploration are not the USA and NASA. The best and so far most unique pictures of Venus were taken by the space project of Russia. The fascinating panoramic images we are about to show you are not from the 21st century either. The incredible technology was developed by Russian engineers and technicians in the 1960s and 70s. The Venera program. In the 1960s, there was a real race between the great nations of the United States and Russia, which was then called the Soviet Union. The Russians sent the first human into space,
Yuri Gagarin on April 12, 1961. In 108 minutes, the first astronaut in human history orbited the Earth and returned to Earth unharmed. In addition, the Russians were already building a first manned space station in the 1960s, which naturally angered the US and spurred it on to conquer the moon as soon as possible. Another very successful program of this period of the space exploration race were the Venus probes of the Russian astrophysicists. In Russia, the goddess of beauty is called Venera, and the probes sent to Venus in the 1960s, 70s, and 80s were Venera 1 through 16. Russian spaceflight initially faced harsh setbacks because the Venera probes delivered images that remain a legend to this day. Venera 1 and 2 flew just past Venus. Venera 3 presumably struck the planet, but technicians lost contact with the probe before it entered the atmosphere. On October 8, 1967, Venera 4 entered Venus's atmosphere and transmitted data for 96 minutes until the probe failed at an altitude of 24.96 kilometers above Venus's surface. A similar fate befell the coming probes, some of which reached the surface but could not withstand the hellish conditions for long. The Russian engineers were not discouraged by this. They continued to improve the probes and had no less in mind than to equip the next probes with such advanced camera technology that they would be able to provide pin-sharp panoramic images of the Venusian surface. The unusual technology of the Venera probes. The engineering achievement of the Venera probes is still considered an early feat of space travel. Technicians were able to build shields and housings that could withstand the temperatures of up to 900 degrees Fahrenheit on Venus for at least minutes, or up to almost an hour. Measurement, radio, and image recording technologies are still among the most sensitive technical equipment today. To accommodate these units in a probe in such a way that neither the heat nor the toxic vapors nor the enormous pressure would immediately destroy them was another master stroke. To accomplish this, the Russian engineers placed a telephoto lens inside the lander, which consisted largely of insulating materials and pressure equalization chambers. Only a porthole, so to speak, peeked out of the thick packing. Using mirror techniques, light from the surface was reflected back through a periscope, which then transmitted it to the camera placed protected inside the probe. To this was added the panoramic camera system, which is no longer a feature today, but was a unique sensation in the 1970s. Although hopes were high, none of the engineers knew whether the first probe equipped with this technology would even reach Venus and successfully photograph it. When Venera 9 was launched on June 8, 1975, another billion-dollar probe flew into space with an uncertain outcome. On October 20th, 1975, the probe successfully entered Venus's atmosphere. The excitement at the control center was great. Venera 9 transmitted data for 53 minutes until it soft landed on the surface and started its camera systems. Unfortunately, only one of the mirrors opened, and instead of a 360-degree panoramic image, only 180-degree images were obtained. But these images were still the very first images humans saw of the surface of Venus. Mostly flattened rocks and soil structures can be seen, indicating volcanism. Only 5 days later, on October 25th, Venera 10 reached the surface of boiling hot Venus. And unfortunately, the problem with the second mirror repeated itself with this probe as well. Again, only a 180-degree image was obtained. The technical-looking elements on the image belong to the probe itself. Otherwise, these images of another region of Venus provided a similar picture to the first images from Venera 9. Endless plains with flat and porous appearing rock and traces of volcanism. Venera 11 and Venera 12 were the first to be equipped with color cameras. However, the technology failed upon impact with Venus, and both probes again provided only data and no photographs in 1978. Meanwhile, Russian engineers continued to work on camera technology. By the fall of 1981, Venera 13 and 14 were ready for launch, and in the spring of 1982, both probes successfully landed on Venus. On March 1st, 1982, the then Soviet Union again made space history when Venera 13 successfully deployed its mirrors and transmitted to Earth these unprecedented panoramic images of the surface of our sister planet. For a full 127 minutes, the successful project delivered razor-sharp images and the first panoramic views of Venus in color. The images again showed a bizarrely flat landscape with loose rock, no water, and hardly any variations in the environment. A yellow sky and a green-brown world, which seems on the one hand very strange, and then again strangely familiar. Surely, apart from the yellow sky, there are similar landscapes on Earth. That the whole of Venus is uniformly covered by wasteland shocks and fascinates at the same time. The mysterious fate of Venus. Venus is a planet very similar to Earth in size and density. In this century, researchers have found that Venus was very likely once a water planet. Many millions of years ago, it had a truly lovely atmosphere, moderate temperatures, and there may even have been life on Venus. Today, it seems that a runaway greenhouse effect, similar to the one we experience on Earth today, has turned this planet into an inhospitable wasteland. As recently as 2020, researchers using a telescope found traces of organic compounds in Venus's atmosphere. There could be remnants of former life on Venus. Since the fantastic images of the Venera missions, explorations of our sister planet have gone dormant. NASA preferred to send its probes to other planets, and Russian spaceflight lay dormant for a long time from the late 1980s for economic reasons. After the appearance of traces of phosphine, a substance produced on Earth only by living microbes, interest in Venus picked up again. A NASA Venus probe is scheduled to launch in 2029. The Da Vinci mission will explore the Venusian atmosphere in a safe orbit. The Da Vinci Plus lander will land on the surface and deliver photos, but the probe will not be equipped with a panoramic camera. Whether the images will provide new insights is questionable. However, it can be said with certainty today that the images from Venera 13 and 14 will remain the best images of the surface of Venus for a long time to come.
The universe is infinite and is expanding with every moment. Even the boundaries of our solar system seem to be forever unreachable. But with the wonder of modern technology and construction, man has succeeded in sending space probes to the edge of our galaxy. We were rewarded with unique images of distant planets. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Seen from the Sun, Uranus is the 7th planet in our galaxy. The distance to the Sun is 2.9 billion kilometers. While a day on Uranus is just 17 hours and 14 minutes, the years on the planet are unspeakably long. Uranus needs 84 years to orbit the Sun just once, so one season lasts about 21 years. It could also take up the volume of about 65 Earths, and has, with 51,000 kilometers, 4 times the diameter. If you put the planet on a scale, you would have the weight of 14 Earths. Only Saturn, Jupiter, and Neptune are heavier. Uranus belongs to the so-called ice giants, not to be confused with the mythical creatures from the Nordic mythical world. This name also applies to Neptune. These giant planets do not get their name because of the low temperatures, but mainly because of their composition of water, hydrogen, ammonia, and methane. Of course, the term ice giant also applies to the temperatures. The average temperature on the surface of Uranus is negative 230 degrees Celsius. The planet was named after the ancient Greek god Uranos, who, according to legend, is said to have been the father of Zeus. The ice giant was discovered in 1781 by astronomer Friedrich Wilhelm Herschel, who at first thought it was a comet. Other planets had been discovered earlier. This is mainly due to the extreme distance of the planet from the Earth. In the best case, this is over 2.5 billion kilometers. The maximum distance, however, is unimaginably large at 3.1 billion kilometers. The journey of Voyager 2. Due to the enormous distance, there has only been one mission to Uranus so far. One has to keep in mind that at a distance like this, the calculations have to be right and the launch of the probe should be timed exactly. So in the 70s, NASA planned a flight that covered the planets Jupiter, Saturn, Uranus, and Neptune. Over the years, the plans were partly rejected and the journey was shortened. So, we can say that we are lucky that Voyager 2 reached all its destinations after all, and can now spoil us with unique images. The spacecraft was launched on August 20th, 1977, but how long did the journey to Uranus take? And how had NASA's technicians made sure that Voyager 2 reached its destinations by the fastest route? The calculations were correct. All 4 planets were in the right place at the right time. By means of a flyby maneuver, which made use of the gravity of the gas planets Jupiter and Saturn, Voyager 2 was able to continue its journey towards Jupiter. It passed through the asteroid belt, and to the astonishment of everyone, Voyager 2 never stopped and continued flying unharmed. The technical breakdowns were within limits. It took 9 years until the space probe finally reached the ice giant. At a distance of 81,500 kilometers, Voyager 2 then took its pictures and sent them to Earth. The moons of Uranus. During its mission, the spacecraft has so far been able to discover and photograph 10 unknown moons of the planet. The 17 known moons have now become 27 known satellites. Miranda, also known as Uranus 5, was not discovered by the spacecraft, but Voyager 2 provided us with amazing and detailed images of the moon. The moon is the smallest of the 5 large inner satellites of the planet and has a unique surface structure. Consisting of canyons, mountain ranges, and craters, we see here an incomparable moon. For the orbit and the rotation, Miranda needs about 34 hours. Somewhat irregularly shaped, in other words, not completely round, the moon's surface area of 700,000 square kilometers is slightly larger than that of France. On the same day, January 24, 1986, the spacecraft took pictures of the largest moon of the ice giant. With a diameter of about 1,500 kilometers, Titania is about half the size of the Earth's moon. However, this puts it in 8th place in the ranking of the largest moons in our solar system. Since the probe naturally could not land on the moon, not everything is known about its exact composition even today. However, it's assumed that the core is rocky and surrounded by water ice. It's also assumed that there is a 50-kilometer frozen ocean on Titania. The first moon newly discovered by Voyager 2 was Puck. Like most Uranus moons, Puck is named after a character from Shakespeare. Also, the moon Juliet is named after a well-known character from a drama by Shakespeare. Can you guess which play the character is from? Perdita, on the other hand, was not discovered until 1999, when the moon was identified and classified in one of the photos. Appropriately, the moon was given the name the Lost One. After Voyager 2 had passed the moons of Uranus, a strong focus was put on the exploration of the satellites. Since then, the rotational properties as well as the trajectories have been studied and researched with the Hubble telescope, among others. Uranus, the ice giant. A photo of the whole planet seems unimpressive at first sight. In contrast to planets like Jupiter, the surface of Uranus seems almost completely unstructured. Also, in terms of color, no big differences can be seen at first glance. A freezing blue runs over the entire surface of the planet. The images from Voyager 2 made it clear that the ice planet is not subject to severe storms or endless storms like most other planets in our solar system. The cloud veil of Uranus is unusually calm, and the weather on the planet is anything but turbulent. It's assumed that the cool inner core is the reason for the mostly relatively unspectacular weather on Uranus. In another photo taken during the onward flight towards Neptune, it looks as if a huge shadow lies over the planet. The edges of Uranus shimmer slightly greenish. How do these colored radiations come together? And what elements does the atmosphere of the planet consist of? The combination of molecular hydrogen, atomic helium, and a small amount of methane gives Uranus its bluish surface. so you could not really set foot on the planet. But if you did, you would have to deal with a gravity similar to that on Earth. At 8.87 meters per second squared, this is about 90% of the Earth's gravitational pull. A man weighing 80 kilograms would therefore only weigh about 73 kilograms on Uranus. The journey of Voyager 2 has by no means come to an end. Even today, it still flies at the edge of our solar system. And still, we can count on it to send us new signals. The distance to Earth is now far more than 15 billion kilometers, and with each passing minute, it moves another 900 kilometers away. So, it will soon leave our galaxy. Only the space probes Pioneer 10 and Voyager 1 have completed another journey. Voyager 2 has revealed astonishing things and provided us with thousands of images. It confirmed that Neptune, Jupiter, and Uranus are surrounded by dust rings. In addition, the probe discovered a total of 22 moons previously unknown. Both Voyager 1 and Voyager 2 have a smorgasbord of cultural assets on board. Among them are records with music and messages. Do you think aliens will discover the records and have a chance to listen to them? Pictures from far away. The space probe Voyager 2 may be the only vehicle that has come within reach of the planet so far. But modern telescopes make it possible to take high-resolution pictures of the Earth. A photo taken by the Keck Observatory refuted the assumption that the weather on Uranus is always calm, because exceptions confirm the rule. The large luminous circles are probably enormous hurricanes moving at lightning speed across the surface of the planet. The rings of the planet. The Keck Observatory took further spectacular pictures from a distance of almost 3 billion kilometers. An infrared image shows the otherwise hardly visible thin rings of the planet. Another infrared image shows not only the rings, but also the small moon Puck, which appears brightly illuminated to the left of Uranus. Voyager 2 also took close-ups of the rings. The stars in the background look like comets. However, this effect only occurred because the probe was already on its onward flight when the image was taken. In the shadow of a moon. The Hubble telescope was also able to take unique images of the blue planet. When the shutter was released at the right moment, the moon Ariel cast a circular shadow on Uranus. Not all questions have been answered yet. It is just as questionable when or if a mission to Uranus will ever take place again. Almost 3.7 billion miles away from the Sun, there exists a small, dark world that was once the 9th planet of the solar system. Today, Pluto is officially just a trans-Neptunian object. Shortly after the planet was downgraded, NASA's New Horizons probe reached this hitherto almost unknown world. The measurement data surprised everyone, and for the first time, NASA was able to publish real images of Pluto. We're now excited to embark on a journey to one of the most unusual celestial bodies in the solar system, together with you. Pluto, world in darkness. Imagine yourselves disembarking as Pluto pioneers from a spaceship, setting foot for the first time on a mysterious dark world. In the vastness, the sun shines as a small, dim ball. The strange and cold world you now find yourselves in is covered by a large shadow. In the semi-darkness, you explore the strangely fragile and porous rock. This world is quiet, very quiet indeed. Due to the low gravity, moving around is difficult. The gravity, only 0.063 times that of Earth, makes you bounce around like light feathers. You have trouble moving forward on the planet. Your shoes have been fitted with weights and spikes so that you can maintain a foothold on the planet. With great effort and difficulty, you are able to bend down to take a rock sample. Then, you climb back into your space capsule to land at another location on the dwarf planet and take more samples. You've trained hard for years for this mission. You were prepared for the unusual situation, the low gravity, and the icy surface of the planet. Pluto is bizarre, dark, yet beautiful. It's a sublime moment to stand on this small and icy cold world so far away from the sun.
After a few hours, the mission is over. The negative 351 degrees Fahrenheit surface temperature only allows for short stays. You take a few more photos of the sun, and then you start your journey home. This is more or less what it would be like for people landing on Pluto for the first time. In the semi-darkness of the outer regions of the solar system, this celestial body is hardly illuminated during the day. The sun is a small, weak yellow ball in the far distance. For a long time, researchers thought that Pluto, being so far out, must be a dead and boring kingdom of rock and ice, and then they experienced a surprise. Pluto, at a distance of about 40 astronomical units, is the closest of the so-called trans-Neptunian bodies. Since its discovery in 1930, Pluto was the 9th planet, but in 2006, it was downgraded to a dwarf planet. It shares this title with a whole host of newly discovered planets that orbit our star at the very outer edge of the solar system, in almost complete darkness. The fact that Pluto has left the ranks of the official planets was received with regret by many people. Although little was known about Pluto, people had been accustomed since 1930 to the fact that there were 9 major planets. For a long time, no one suspected that many more dwarf planets would be found in the Kuiper Belt. Eris and Sedna are just a bit smaller than Pluto, and scientists were faced with the choice of classifying these 2 and many more newly discovered objects as planets, or drawing a line. Since Pluto is much more similar to the trans-Neptunian dwarf planets than its neighbors Uranus and Neptune, the scientists decided to strip Pluto of its planet status. Since then, it has officially been called, simply, TNO 134340. From darkness into light. It seems almost ironic that shortly after its demotion, Pluto showed how fascinating and unique it really is. Pluto is extremely difficult to observe, and even in images from the Hubble Space Telescope, the dwarf planet looked like a hazy brown disk without any surface details. Since it was impossible to adequately explore Pluto with telescopes and from afar, NASA sent the unmanned New Horizons probe to Pluto in the very year of its demotion. It took the probe a whole 9 years and 8 months to reach its distant target. When it finally reached its primary target in 2015, New Horizons immediately got to work and surprised not just the scientists. In a very short time, the probe collected 6 gigabytes of information, and it took more than a year to transmit this large amount of data to Earth. To this day, planetary researchers are still analyzing the data. Until this point, no human had ever really seen Pluto's surface, and suddenly, a colorful and apparently very active world was revealed to the curious scientists. The images of the strangely varied, structured surface of the planet revealed an unexpected geological activity. Although New Horizons was not able to penetrate to the core of the planet, the measuring devices nevertheless delivered data that for the first time allowed conclusions to be drawn about the structure of the planet. According to the resulting model, Pluto has a solid core, about 1,056 miles thick, made up of a mixture of various substances and elements. The upper layers consist of water ice and rock. The ice of the crust is in places probably up to 186 miles thick. It's quite possible that Pluto carries liquid water under this ice layer. Active geothermal structures and ice volcanism show that Pluto's core processes heat. According to some assumptions, Pluto's core could generate enough heat to melt a portion of the icy mantle. In this case, a very salty and poisonous ocean containing large amounts of dissolved ammonia could be hidden deep beneath the surface of the dwarf planet. Quite unlike on Earth, the geological processes on Pluto rely less on water, ice, and rock. Rather, this planet mobilizes masses of crystallized gases like nitrogen, methane, and carbon monoxide. Planet with a heart, the Tombaugh Regio. Our journey across the surface of Pluto begins with the most striking and best-studied area, the Tombaugh Regio. This vast region in the equatorial zone of the planetoid resembles a heart and is unofficially also called the Pluto Heart. At a size of about 1,429 miles, the area takes up about a quarter of the entire surface of the celestial body. The heart is divided into a bright left side and a darker side. The left section forms a landscape called Sputnik Planitia, or Sputnik Planum. Sputnik Planitia has a diameter of 927 miles, and the topographic map shows that it's an extensive lowland area with a thick layer of nitrogen ice, carbon monoxide, and solid methane. These substances have a bright coloration, which makes some parts of the plane reflect up to 90% of the incoming light. There are virtually no craters, indicating that the region is geologically very young. Sputnik Planitia probably formed about 100 million years ago when Pluto collided with a large celestial body. The impact left a huge crater, which was later filled with substances from the warm interior of the dwarf planet. This created a unique cell or honeycomb-like structure, which is unusually lively. A comparison with observational data from the new James Webb Space Telescope has shown that the structures have significantly migrated in the last 8 years. This is an indication of the ongoing geological activity. Tombaugh Regio is bordered by relatively high mountain ranges. The mountains of Hilary Montes, to the west of Sputnik Planitia, may not be among the largest in the solar system, yet they are comparatively large, with heights of up to about 1.86 miles. The Townsend Montes are located in the southern part of the heart. Some of them rise over 3.72 miles above the average surface level of the dwarf planet, forming the highest mountain range on Pluto. Remarkably, these rocks are likely primarily composed of water ice. At the low temperatures on Pluto, water ice is as solid as rock. Cryovolcanism on Pluto. Further south, a deep depression shapes Pluto's exterior. Surrounded by massive, stratified ice ridges and rocks, the structures show clear evidence of cryovolcanism. The surrounding rocks are very likely solidified ejecta from old eruptions. Thanks to the new color images, researchers were able to learn details about the chemical composition of the eruptions for the first time, and thus also find out how Pluto is structured internally. The eastern part of Tombaugh Regio is darker. The landscape here is much older. The craters are probably billions of years old and were created by asteroid or comet impacts. Unlike Sputnik Planitia, this region shows no signs of active geological processes. If we continue traveling east along the equator, we encounter a chain of dark spots called maculas. The landscape here is intersected by high mountain ranges that stretch for several hundred miles. How the maculas were formed is a mystery that scientists are currently still researching. It's suspected that their dark color comes from a combination of impact craters and tholins. Tholins are complex organic compounds formed by the action of high-energy radiation on simple molecules in the atmosphere of celestial bodies, influencing their optical properties. Lowell Regio. We leave the rugged world of the maculas behind us and head further north. There lies Lowell Regio, the expansive valley that surrounds Pluto's North Pole. Because Pluto's axis of rotation has a significant tilt to the plane of its orbit, this region is the brightest on the planet. Pluto always moves with its North Pole facing the Sun. It is suspected that this is why the density of Pluto's atmosphere has tripled over the past 30 years, despite the increasing distance from the Sun. It's likely that the Sun's rays cause nitrogen ice to evaporate, which then settles at the pole and enters the dwarf planet's atmosphere. Charon. The strange movements of Pluto have a good reason. The particularly inclined orbit with cyclic oscillations around a focal point is caused by the moon Charon. Pluto's moon Charon is comparatively large with a diameter of about 753 miles. Pluto itself has a diameter of about 1,476 miles. The two orbit each other at an average distance of about 12,172 miles. Both celestial bodies resemble a binary system more than a planet and a moon, although Pluto clearly leads the pair. The cosmic dance of the two was first documented by New Horizons and is currently also part of intensive exploration. Charon is not only very large for a moon, it also resembles Pluto in many ways. However, its surface is even darker. Nevertheless, images from New Horizons showed evidence of water ice mixed with methane and nitrogen and unusual geological activities. Experts suspect that the Kuiper Belt will continue to offer potential for new discoveries for decades to come. So far, only a tiny part of this region of our solar system is known. Saturn's mysterious beauty has always held a fascination. With its ring system, the planet is unique at the threshold of the inner solar system. And now, thanks to unprecedented technological advances, we are rushing from milestone to milestone in space exploration. Images of Saturn's majestic rings, its moons, and mysterious storms have rocked the world of science. But the visual splendor is just the beginning. NASA scientists are stunned by the discoveries these images have brought. Join us on this journey and sit back and relax as we push the boundaries of the unknown. A distant, mysterious world. Tiny and blue, the Earth appears from the perspective of Saturn, the guardian of the threshold, the last of the inner planets, and the mysterious bearer of a ring system, was studied by the Cassini space probe for the first time as never before. Gas giants like Jupiter and Saturn are of particular interest to science because they are among the first planets to form in the young solar system. They carry the secrets of the early solar system, are massive, powerful, and worlds of superlatives. Constructing probes that can take the long way around and then hold their own in the environment of the gas giants is a challenge. The magnetic forces of the gas giants are so immense that smaller objects are usually simply sucked in by them. When the Cassini spacecraft set out on its journey, no one knew how long this mission would go. Cassini was the fourth NASA spacecraft to visit Saturn, but it was the only one sent out for the sole purpose of studying the mysteries of the gas giant and its moons. Titan, a moon orbiting the planet, offers the prospect of discovering the first life forms beyond Earth. That's why Cassini wasn't alone. Aboard a Titan 4B Centaur rocket, the largest dual probe ever launched into space on October 15, 1997. Cassini and the lander Huygens together brought it to a proud launch weight of 5,000 kilograms. Huygens was a project of the ESA and was the first man-made object to land on a moon other than Earth's moon and a celestial body in the distant outer solar system. To reach Saturn, Cassini and Huygens flew several swing-by maneuvers and passed Venus for the first time 6 months after launch. Another flyby followed in 1999. Equipped with enough momentum, it went straight through the asteroid belt and on towards Saturn. Before that, Cassini first approached Jupiter in December 2000. During the 6-month flyby, 26,000 new images of the gas giant were taken. Although Jupiter was not Cassini's primary target, we have the probe to thank for one of the best color portraits of Jupiter. The image of Jupiter's moon, Io, is also stunning. In February 2004, the time had come. Cassini approached Saturn. First, the probe discovered 7 new moons and photographed Saturn's already known moon, Phoebe, passing by. The images taken by the spacecraft revealed parts of Phoebe's heavily cratered surface. Thanks to these unique photos, we now know that a large amount of water ice very likely exists between the surface on Phoebe as well. Arrival. Huygens lands on Titan. It took 7 years for the Cassini-Huygens mission to enter Saturn's orbit for the first time. The probe headed for Titan with determination. As one of its first actions, Huygens was to make its spectacular flight to the surface of the moon. The special thing about this landing was not only the fact that a landing on an alien moon was a first. Titan was considered the most Earth-like celestial body in the solar system at the time, and the moon offered an excellent prospect of finding life beyond Earth for the first time. Huygens entered Titan's atmosphere on January 14, 2005, and no one knew what would be seen in the next 2 hours. Titan shrouds itself in a dense atmosphere, and no human has ever been able to glimpse into its surface, even with the best telescopes. However, measurements have shown that Titan has nitrogen in its atmosphere, rocks, water, and very likely a weather-like cycle. When Huygens landed on Titan, the probe revealed that Titan's lakes and seas are mostly methane. Although there was also some disappointment, the discovery of the first lakes in a place other than Earth was akin to a miracle. We now know that simple living things can exist on Titan, despite the unusual elements. Experiments in the laboratory prove that bacteria and microbes can very well exist on the basis of methane. At this stage, we know too little about the actual origin of life to to rule out the possibility that such a world cannot also give rise to higher life. Once on the surface, Huygens continued to send data for about 90 minutes. The mission was brief and one of the most memorable in the history of spaceflight to date. Saturn and its moons. While the landing of Huygens had been brief and brilliant, Cassini launched a 20-year exploration effort in the service of humanity. In the process, the probe covered about 8 billion kilometers and completed 294 orbits around Saturn. After Titan, Enceladus, the icy moon, was to be the next target. The spacecraft observed active ice volcanism and even water ice geysers at the moon's south pole. The mission's findings showed signs of the presence of an inner, liquid, and salty ocean. It's possible that life exists there, as Enceladus appears to have an active hot core in its interior. The next highlight of the mission was several flights through Saturn's ring system. Cassini revealed that Saturn's rings are more jagged than smooth, and that these irregularities are most likely due to Saturn's enormous gravitational pull. In the G-ring, the spacecraft found numerous water ice particles, which are ejected into the gas giant's environment by ice volcanism on Enceladus. Other rings are composed of dust or small particles. The rings are unique in our solar system, but not in the universe. Researchers found an exoplanet far away from us whose ring system is 30 times larger than Saturn's. Nevertheless, the rings, which remind a little of the grooves of old records, are fascinating. I wonder what melody would sound if we could play these rings on a record player. Do you have an idea? Then share it with us in the comments after the video. Within the rings, smaller moons are probably always forming, or moons and pieces of rock collide and their debris form new rings. Although we have unique measurement data and images thanks to Cassini, the formation of the ring system is still a mystery to science. The Great White Spot. As space enthusiasts, you probably all know about Jupiter's Great Red Spot, but do you know about Saturn's Great White Spot? Every 30 years, a massive storm erupts in Saturn's gas envelope. On October 25, 2012, Cassini, and with it, dozens of astonished scientists on Earth, were allowed to witness the storm event. The weather phenomenon was first discovered in 1990 by the Voyager 1 spacecraft. Size-wise, the spot can't quite keep up with the big red spot on Jupiter. Our Earth would have fit there 3 times in its prime, and the Great White Spot on Saturn, with a width of up to 13,800 kilometers, is only about half the size of Earth. The storm also differs significantly in duration from its counterpart on Jupiter. The white spot often lasts only a few months, sometimes even years. Jupiter's red storm, on the other hand, has been raging for several centuries. The white spot consists mainly of ammonia clouds. The interaction of sunlight with the atmospheric gases further contributes to the play of colors between white and yellowish. As far as wind speeds are concerned, the white spot even surpasses the red spot because speeds of up to 500 kilometers per hour are among the highest ever measured in the solar system. But the king of the winds is clearly Neptune, whose wind speeds can sweep across the surface at up to 2,100 kilometers per hour. The white spot is not the only strange storm and weather phenomenon on Saturn. At the North Pole, there is a storm that is not only enormous, but also has a very strange shape. So far, scientists cannot explain why this permanent storm shows the shape of a perfect hexagon. In 2013, Cassini filmed the storm at the highest resolution. Close examination of the image revealed that there might be something like a blue sky in the deeper regions of the storm hole. Researchers were shocked by this finding. Could it be that the depths of the gas planet hide a completely different face or even a landscape? All we know is that space is full of mysteries. We can never say for sure that something is so, or rule out something until we have seen it with our own eyes. This is precisely why space exploration with probes is so important. Cassini was originally supposed to spend 7 years exploring space, but the probe proved so durable and long-lived that NASA could extend the mission several times. No one knew how long Cassini would last, given Saturn's immense magnetic forces. But once again, humans created a piece of engineering that outdid itself. In 2017, Cassini's fuel was finally running out, and that definitely heralded the final phase. On its final flight, Cassini traversed Saturn's ring system one more time. On September 15, 2017, officials at NASA's Mission Control Center directed Cassini on its final flight path, and it would lead directly into Saturn's atmosphere. For the scientists, this was both a tragic and a joyous moment. After all, in this way, they were getting measurement data from a place from which no probe could ever return. But entering Saturn's atmosphere also meant the end of a brave probe that had accompanied the lives of mission members for 20 years. The controlled crash was the only way to safely dispose of Cassini. NASA could not possibly risk Cassini remaining in orbit and possibly crashing on one of the moons one day. At this time, we cannot rule out the possibility that Cassini was contaminated with terrestrial bacteria. To prevent an alien world like Titan or Enceladus from coming into contact with our bacteria in this way, the probe had to end up where there is certainly no life. This was the last shot before Cassini's cameras failed. Cassini nevertheless continued to send data during the crash for much longer than scientists had dared to hope. The end came from the massive gravitational pull. Presumably, the probe was crushed inside or blown to pieces. It's quite possible that individual parts of the probe are still swirling through the gases of Saturn and perhaps also through the Great White Spot. We will probably never know.
On March 3, 1972, the time had come. Pioneer 10 was the first space probe to leave our blue home planet and set off for the giant Jupiter. In the following decades, 6 more unmanned spacecraft were to reach the realms of the gas giant. Over the course of these exploration missions, we not only gained important insights into the largest member of our planetary system and its moons, but also breathtaking images of the planet. Excited about great mysteries and amazing discoveries in the universe? Then subscribe to our channel and click the bell to join us on our galactic journey and never miss another one of our videos. Feel free to show us with a thumbs up that we can keep you engaged with the content of our posts. Jupiter, a brief overview. No other planet in the solar system has such massive dimensions as Jupiter. In detail, the diameter of the celestial body amounts to a fabulous 89,000 miles. For classification, in theory, our Earth would easily fit more than 1,000 times into our gigantic neighboring planet. These impressive dimensions ultimately mean that we can clearly see Jupiter in the sky, even though there is a gap of more than 360 million miles between us and this imposing celestial body. In contrast to the terrestrial planets in the solar system, Jupiter does not have a solid composition. Thus, the celestial object named after the Roman chief god is classified as a gas planet. With increasing depth, the gases that make up Jupiter eventually enter a supercritical state. This means that the corresponding substances are in a special thermodynamic state within which the properties of liquid and gaseous states of matter are combined. Although Jupiter consists mainly of volatile chemical compounds, first and foremost, hydrogen and helium, many experts nevertheless consider it possible that the gas giant has a solid core. The colossal heart of the planet is probably composed of ice and rock and has a mass 20 times that of the Earth. This chemical composition also allows Jupiter to achieve a fabulous intrinsic rotational velocity. Although many times larger than the Earth, the gas giant needs less than 10 hours to rotate once around itself. The forces that act on the planet as a result of the rapid rotation speed ultimately lead to the fact that the celestial body presents itself much slimmer at its poles than at its equatorial plane. In simple terms, Jupiter is thus somewhat compressed and appears more wide than high. It takes 12 years for the largest planet in the solar system to orbit the central host star. On average, the two celestial objects are separated by a distance of 480 million miles. Consequently, the mean temperatures prevailing in the upper layers of the gas giant also drop to bone-chillingly cold depths. On average, the thermometer here rises no higher than -162 degrees Fahrenheit. However, the deeper we penetrate into the interior of the gas planet, the further the temperatures rise. In combination with the steadily increasing pressure conditions in the innermost regions of the planet, the condition of the substances present there also changes. Meanwhile, it's known that the galactic colossus is surrounded by at least 79 moons.
The largest and by far the best known of all Jupiter's satellites are the 4 Galilean moons. As the names of these satellites suggest, Ganymede, Callisto, Io, and Europa were discovered and described by none other than the world-famous Italian explorer Galileo Galilei. The galactic giant. A look at the overall view of the planet shows us what diversity characterizes the gas giant. Particularly memorable are the striking stripe patterns that adorn the planet along its equatorial plane. As we can see in the image taken by the Cassini spacecraft, these characteristic patterns come not only in different sizes and shapes, but also in different colors. In detail, these galactic colors are created by the different gases that exist in Jupiter's atmosphere. These are mainly ammonia and sulfur structures, which are sharply distinguished from each other. The detailed investigation of these structures ultimately led to the realization that the gas orbits undergo regular changes. These changes affect not only the extent of the distinctive streaks, but also their coloration. A closer look at these breathtaking images shows us that the countless orbits are repeatedly peppered with conspicuous, small white dots. What at first appears to us on the overall view of the planet to be extremely small structures are in fact raging storms that regularly sweep across Jupiter. The Great Red Spot. The magnitude of the whirlwinds on planets the size of Jupiter becomes clear to us if we concern ourselves with the so-called Great Red Spot. This is a raging anticyclone whose diameter is about 1.5 times that of our blue home planet. The gigantic structure has been raging for at least 200 years in the top atmospheric layers of the gas, and possibly much longer. What causes the typical coloration of the Great Red Spot is still a galactic mystery. What is certain is that the structure rises up to 5 miles above the surrounding cloud cover, and in the recent past has become significantly smaller and more circular than before. Experts suspect that these changes are due to interactions with other storms on Jupiter. Other storm formations. As we can immediately see in the general view of Jupiter, the gas planet is not only graced by the Great Red Spot, but by quite a few other whirlwinds. These whipping formations often reach speeds of more than 300 miles per hour and prove to be much more durable than their terrestrial counterparts. Of course, the whirlwinds have a direct impact on their immediate surroundings. As soon as the structures slowly subside and finally come to a standstill, significant temperature differences occur between the poles and the equatorial region. The so-called white oval, a structure roughly the same diameter as our Earth, represents the merger of 3 originally independent storms. Images taken by the Hubble Space Telescope show that the coloration of this structure changed from white to red over time. The hurricane, which reaches wind speeds of up to 370 miles per hour, is therefore also called Red Spot Jr. Since 2008, we know that another, third red storm is also raging on Jupiter. Jupiter's North Pole. The following is a computer-generated image based on an infrared image of the gas giant's North Pole. This image shows impressively that the polar regions of the celestial body are accompanied by stormy conditions. More precisely, the image shows the structure of a unique cyclone pattern. The center of this roaring structure is a large, central cyclone, which in turn is surrounded by 8 independent storm structures that have a diameter of between 2,490 and 2,860 miles. The South Pole of the giant. The opposite polar region is also afflicted by an extreme storm formation. Just as at the North Pole, we find a unique association of powerful cyclones in the southern reaches of the celestial body. Here too, a large cyclone forms the center of the structure, around which 5 other cyclones have settled. The diameter of these structures oscillates between 3,480 and 4,350 miles. Like practically all formations that adorn the large representative of our planetary system, these cyclones are also subject to constant change. Galilean moons. To conclude today's excursion into the realms of Jupiter, we would like to take a look at the 4 large satellites of the gas giant. What immediately catches our eye when we look at Europa, the largest of the Galilean moons, are the numerous cracks and trenches that decorate the surface of the satellite. Beside these breaks of the surface structures,
which developed in the course of dynamic processes in the soil. It's, however, above all, an urgent observation concerning Jupiter's moon that holds us spellbound. Experts are convinced that under the thick ice cover of the satellite, a subglacial saltwater ocean of unimagined scale exists. Ganymede. With an equatorial diameter of 3,200 miles, Ganymede is not only Jupiter's largest natural companion, but also the largest known moon in the entire solar system. The strong magnetic field also makes this celestial body unique among the moons. The thick ice crust, which adorns the surface of Ganymede, is peppered with the most diverse landscape formations as a result of numerous tectonic activities. These countless impact craters have always been characteristic to the face of the moon. Io. The surface of the innermost of Jupiter's 4 large moons, Io, resembles a fiery patchwork quilt. This moon hosts dozens of volcanic formations, many of which remain active to this day. In fact, no other known celestial body in our solar system exhibits such pronounced volcanism as Jupiter's galactic companion. However, most of the volcanoes we find on the satellite are not fire mountains in the classical sense, but so-called calderas. These are cauldron-shaped depressions on the surface that regularly spew smoke and ash. Callisto. With a diameter of 3,000 miles, Callisto ranks second in the list of Galilean moons sorted by size. The satellite's rugged surface testifies to the fact that Jupiter's moon has been hit by countless galactic missiles in the past. Callisto, along with Saturn's moon Phoebe, is one of the moons in the solar system with the highest density and number of meteorite craters. Just as in the case of Europa, researchers believe that a subglacial sea could lie dormant beneath the partially 200-kilometer thick ice surface of the satellite. Your opinion interests us. Which image of the gas giant and its moons fascinated you the most? We look forward to reading your thoughts on today's video in the comments. Finally, feel free to take a look at the other exciting posts on our channel that we've linked for you in the credits. Thanks for watching, take care, and we'll see you next time.